In this problem, we're told that a plane is headed from Ohio to Cincinnati, Ohio to Tallahassee, Florida. So I will just go ahead and mark them, and trying to make it somewhat geographical. So, this would be Cincinnati up here, and we'd have Tallahassee somewhere down here. And we're told that the goal is to take this path. Let's see if I can draw it. So to take this path right here, so I'll make a straight line path from Cincinnati to Tallahassee, which has a distance of 738 miles. We know that the plane actually veers off course by 5 degrees. So it doesn't really matter which way you draw it, down here or over here. It's just 5 degrees off course. And so I'll draw it going this way. So it actually suppose that it heads a little more east than it's supposed to. And this is 5 degrees for this angle right here. Okay, well, so this is where the plane is after we know that the total distance traveled. Well, we don't know that. We just know that it goes at a rate of 210 miles per hour times the time, which is half an hour. So we have to do 0.5 hours. Since this is miles per hour and this is the number of hours, we know that the plane has gone a total of 105 miles in the wrong direction. And the question is, at what angle should he turn to get back on track? Okay, so the plane really should start going this way now. So the first thing we need to know is to figure out this angle right here. Okay, well, we've got to do a little bit of work to get that. Let me just go ahead and relabel this triangle, just so we have the mathematics of it and not the practicality of the situation. And we'll come back to that, interpreting that a little bit later. But let's just work with the math right now. So we know that this angle that we're calling A right now is 5 degrees. We know that little b is 738. We know that little c is 105. And so now we analyze the information that we have, and we find that we have a side angle side. So we have a side angle side. And so what does that mean we can use? Well, if we look back, this is a perfect situation for a law of cosines. And so I'm going to mark law of cosines. That's what we're going to need to use in order to gain more information here. And so the first thing we really have to calculate is, well, we have an angle. We don't have the side opposite, so let's solve for A. That's all we really can do because we have side B, side C, and angle A. And remember that when you use the law of cosines, you need minus 2BC cosine A. If you have the angle, then you need to be finding the corresponding side. If you have a side, then you're going to be hunting for the corresponding angle. So we're going to plug in everything we have. We have B is 738, and that's 738 squared, plus C squared, which is 105 squared, minus 2 times 738 times 105, times the cosine of A, which is 5 degrees. So we'll go ahead and square root this and just write it the way we'll enter it into the calculator. So I won't even evaluate anything here. I'll just write it all out, and we'll just enter it in one fell swoop. So 738 times 105 times cosine of 5 degrees. We just have to make sure that we're in the correct mode. So we want to be in degrees since we're dealing with 5 degrees. And so I will exit, and I will just go ahead and do the square root of 738 squared plus 105 squared minus 2 times 738 times 105, close the parenthesis, and so we get that that side equals 633. So we come over here and we'll label this guy 633. So now what do we have left? Oh, and that's kind of convenient that it came out to be, well, actually, you know what, we made a mistake. We've got to incorporate the cosine of 5 degrees in there, so I'm going to go ahead and fix that and just put in cosine of 5. It will seem kind of odd that we would get a whole number. And so that should change it a little bit. And we actually get 633 and a little bit of change. So what I'm actually going to do here is I'm going to carry out the rounding a little bit. So even though I know we've talked about actually having this rounded to the nearest whole number since all the other sides are, I think the first time I worked this problem out, I ended up solving for another angle, and it came out as 180 degrees, and that became problematic because, of course, you're already over just with the two angles already known. So I'm just going to round this out to 633.466. This is usually not an issue, but if you ever do run into it, that just means you should round a little bit further. So we ultimately want to know this angle right here, and we're ready to solve for that. Now we do have a couple of different options because we have side angle side, now we have side side, we have side angle. So we can go a couple of different routes on here. We can use law of sines, but I'll just go ahead and use law of cosines again, just for consistency. So we have A, B, and C, and now we need to solve for angle B. So that means I'm going to use this form of it. B squared equals A squared plus C squared minus 2AC cosine B. And I'm going to fill in what I have, so I know 738 squared equals A squared, which is 633.466 squared, plus C squared, which is 105, minus 2 times 633.466 times 105, kind of getting all over the place here, times the cosine of B, which is what we're trying to find, so we'll end up isolating that. And so I'm going to kind of do a lot of arithmetic here all at one time, or algebra, so I'm going to subtract the 633.466 squared from both sides, subtract the 105 squared from both sides, and I'm going to divide. So right now what I have left on the right hand side is just negative 2 times this junk times cosine of B, so I'm going to end up having to divide by this. And if you need a couple extra steps, you're of course welcome to show more work than this, but I think it's just convenient to do it all in one step so you don't have to write it down so many times. And now finally we're going to take the inverse cosine, but I guess we could do that all at once. We can just say the inverse cosine of what? Well, of all of this stuff here, so this whole thing gets plugged into the parentheses, and I'll just write that as such so we don't have to copy it all down again. And now I will find the inverse. So I'm going to come back to my calculator and I'm going to say I need to know the inverse cosine of, well, the numerator I'm going to put in parentheses, 738 squared minus 633.466 squared minus 105 squared. Okay, close the parenthesis for the numerator, divided by, I'm going to open a new numerator, negative 2 times 633.46 times 105. Now even though I used parentheses in the actual written portion, I don't want to have too many parentheses so I don't lose track of how many parentheses I have open and how many I need to close. So that pretty much wraps up the denominator. Now I'll close the parenthesis on the inverse cosine, and I get that B is 174.18. Well, now we can go ahead and round, because again, if we had used 633, so let me just show you what would have happened if we had rounded to 633. If we had rounded to 633, we would actually get a very unpleasant answer. Not so much unpleasant as, well, what do we do? We would have gotten exactly 180. Now, because that would have just been one angle, we would have been an impossible triangle already at that point, because you can't have 180 degrees for one angle. It's not a triangle. So our little rounding scheme here actually ensured that we'd get something that's under 180. So that's what rounding error does, just FYI. And so we know now that B is about, we can go ahead and round it now, so 174 degrees. Okay, so I've got a lot of stuff on here. It's getting kind of messy, kind of confusing. So we now filled in this angle. Now the question is not what is that angle between where the plane is going and where direction in which it should be heading. The question is at what angle should he turn to get back on track? So off to the side here, just to add more messiness, we're going to say, okay, well, he's going this way, and now he wants to basically turn so that this angle here is 174 degrees. Well, now he's heading straight, so I'm going to draw this dotted line showing where he would be headed if he kept going. But what the plane's actually going to do is it's going to turn so that it's heading this way. Right now, obviously it's going to happen before, so he makes that turn just in time, but this is really the angle that we're trying to measure right here, because this is the full length he has to turn. So what is this angle right here? Well, notice that this is a straight line, so this angle breaks up 180 degrees, so that means he would have to turn 6 degrees. So turn 6 degrees so that you're headed in the right direction. So that would be our answer to part A. So just say answer. All that messiness. B, how fast should the pilot fly the plane to get to Tallahassee in 4 hours? Well, we know how far he has to go to Tallahassee. We actually had to solve for that on the way to getting the answer that we wanted. So he needs to, remember, distance equals rate times time, and he needs to travel 633 miles. At this point, it's okay. I mean, I guess just to be consistent, we can use 0.466, but here it's not going to matter because we're solving for a speed. Rate times time, well, how fast or how long does he need to get there in 4 hours? So we'll put the number of hours here. And now we just divide by 4 to solve for the rate. And we get 633.466 divided by 4 gives us he'll need to travel about 158.37 miles per hour. And that's it. We're done.